We tore down Ford, Chevy, and Ram transmissions with over 200,000 miles on them. And what we found inside surprised even me. I've rebuilt transmissions for over 15 years, and I expected these three trucks to show similar wear patterns since they're all doing the same job, hauling, towing, and commuting for hundreds of thousands of miles. Instead, one platform separated itself from the other two so clearly that it changed how I recommend trucks to customers who plan on keeping them long-term. Today we're breaking down what we found inside the Ford 10R80, the Chevy 10L90, and the Ram ZF8HP75 after real-world mileage, what failed, what held up, and which one owners should actually trust to go the distance. Let's get into it. I want to start with the truck that actually got this whole comparison started, because it wasn't a planned project at first. A customer brought in his 2016 Silverado with 210,000 miles on it, complaining about a shudder he felt every time the truck settled into cruise on the highway. He'd owned an F-150 before this truck and swore the Ford never did that at similar mileage. That offhand comment stuck with me because on paper, these two trucks should behave almost identically under the hood when it comes to the transmission. So we started pulling data from every high-mileage Ford, Chevy, and Ram that came through the shop over the following months, and a pattern emerged that was too consistent to be coincidence. Let's start with why this comparison matters in the first place. All three of these transmissions came out around the same era, and all three are 10-speed units except for the Ram, which uses an 8-speed. Ford and GM actually co-developed their 10-speed transmission together, so on paper, the 10R80 in the F-150 and the 10L90 in the Silverado should behave almost identically. Ram went a completely different direction, licensing a version of the ZF8 HP 8-speed that originally came out of Europe, the same basic architecture used in BMWs and other performance vehicles. So going into this, I expected the Ford and Chevy units to perform nearly the same, with the Ram being the wild card. What actually happened was different. We pulled data and physically inspected transmissions from trucks that came through our shop with 200,000 miles or more, all with documented maintenance history, so we knew we were looking at real wear rather than damage from neglect. This wasn't a controlled dyno test with brand new trucks. This was years of watching what actually comes apart on a lift when high-mileage trucks need transmission work, cross-referenced with fluid analysis and clutch pack inspection on units we serviced or rebuilt. That distinction matters because a lot of comparison videos rely on manufacturer claims or short-term ownership surveys. We're looking at what these transmissions actually look like on the inside after a decade of real use. The Ford 10R80 has generally earned a solid reputation, but it didn't get there without some growing pains. Early production units, especially 2017 through 2019 model year F-150s, had a well-documented harsh shift complaint, particularly the 1-2 shift, feeling like a hard bump rather than a smooth transition. This wasn't a mechanical defect in most cases. It was a transmission control module calibration issue, and Ford issued multiple software updates to smooth out the shift mapping. Trucks that never receive these updates tend to show more accelerated wear on the clutch packs responsible for that first to second gear shift, because the harsh engagement puts more stress on the friction material every single time it happens. When we tear into a 10R80 with 200,000 miles that never had the TCM update, we consistently see accelerated wear on the intermediate clutch pack compared to units that were flashed with the updated software early in their life. Beyond the software issue, the 10R80 uses a torque converter with a wide gear ratio spread, which is great for fuel economy and towing flexibility, but it also means the converter clutch is engaging and disengaging more frequently than a traditional 6-speed design. Over 200,000 miles, we see torque converter shudder show up more often in this platform than I'd like, especially in trucks that go long stretches between fluid services. Ford recommends fluid changes at 150,000 miles under normal conditions, but for a truck doing regular towing, that interval is too long. The units we saw with shudder complaints were almost always on the original factory fill or close to it. When the fluid was replaced on schedule, roughly every 60,000 to 80,000 miles for trucks under load, the converters held up dramatically better. The solenoid pack inside the 10RD R80 is also a common wear point. It's a serviceable component, which is actually a point in Ford's favor since you don't need a full transmission replacement if a solenoid fails. We've replaced solenoid packs on 10 R80 transmissions at various mileage points for a few $100s in parts versus the alternative of pulling the entire unit. Overall, the Ford held up reasonably well structurally. The planetary gear sets and case showed normal wear consistent with mileage, and we didn't see widespread catastrophic failures in properly maintained units. The main story with the Ford was that early software calibration created stress that showed up later as accelerated clutch wear, and the converter needed more frequent fluid attention than the factory schedule suggested. One more detail worth mentioning on the Ford side is the pump assembly. The 10R80 uses a variable displacement pump designed to reduce parasitic drag and improve fuel economy at cruise. At high mileage, we occasionally saw wear on the pump's control valve that led to inconsistent line pressure, which shows up as a slightly delayed or soft shift feel rather than a hard failure. It's a relatively inexpensive fix compared to internal clutch work, and it's often misdiagnosed as clutch wear by shops that don't pull the pump and inspect it directly. Trucks in our sample that had this pump issue addressed early, rather than being written off as needing a rebuild, saved their owners thousands of dollars in unnecessary repair costs. Now let's talk about the Chevy 10L90 because this is where things got interesting despite sharing so much engineering DNA with the Ford unit. Since GM and Ford co-developed this transmission family, you'd expect nearly identical results. Instead, we found the Silverado's version of this 10-speed showing more torque converter shutter complaints and more clutch pack glazing than the Ford, even accounting for similar mileage and towing use. The reason comes down to tuning and cooling more than hardware. GM's transmission control software historically runs the torque converter clutch in a wider range of driving conditions to maximize fuel economy numbers for EPA testing. That means the converter clutch is locking and unlocking in situations where the Ford's calibration might leave it in a more traditional hydraulic coupling mode. More lockup cycling under load creates more heat cycling, and heat cycling is the primary enemy of clutch material and transmission fluid life. When we pulled fluid samples from Silverados around the 150,000 to 200,000 mile mark, we consistently saw darker fluid with more friction material suspended in it compared to F-150s with similar mileage and similar towing history. There's also a cooling consideration. The Silverado's transmission cooler, particularly on trucks without the max tow package, is undersized relative to how hard GM's calibration works the converter clutch. Trucks equipped with the factory tow package and its larger auxiliary cooler showed noticeably less wear than base cooling package trucks doing similar work. This is a case where the option box you check at the dealership genuinely changes long-term durability, not just towing capacity on paper. If you're looking at a used Silverado or Sierra and you plan on towing regularly, checking for the max trailering package isn't just about payload numbers, it's about whether that transmission has a fighting chance at 200,000 miles. We also saw more instances of the 10L90 needing valve bodywork in the 150,000 to 180,000 mile range compared to the Ford. The valve body controls fluid pressure to the clutch packs, and when solenoids inside it start degrading, you get delayed engagement, flared shifts, or harsh shifts that mimic clutch wear, even when the clutches themselves are still within spec. This is a repairable issue, generally in the $800 to $1,500 range depending on labor rates, but it's a repair we saw far more often on the Chevy side of this comparison than the Ford side, despite the transmissions sharing a common design lineage. My take after seeing this pattern repeatedly is that GM's software calibration, aimed at squeezing out every fraction of a mile per gallon for fuel economy ratings, comes at a real cost to long-term clutch and solenoid life. It's a case where the same hardware performed differently because of how the two manufacturers chose to run it. We also paid close attention to bearing wear inside the 10L90, since a shared architecture with the Ford means the internal bearing sizing is nearly identical. Here, the two platforms lined up closely, which actually reinforces the idea that the hardware itself isn't the problem. The output shaft bearings and the bearings supporting the planetary carriers showed similar wear patterns at similar mileage between the Ford and Chevy units, consistent with what you'd expect from shared engineering. The divergence really does trace back almost entirely to how aggressively each manufacturer chose to run the torque converter clutch, and how each cooling system was sized for the options a given truck came with from the factory. If you're finding this breakdown useful, go ahead and hit that like button now, because we're about to get into the Ram. And this is where the results genuinely changed my opinion on which half-ton truck I'd recommend for someone planning to keep their vehicle past 200,000 miles. The Ram 1500's ZF8 HP 75 8-speed came into this test as the outlier, both in gear count and in design philosophy. This transmission traces its roots back to a design used across a wide range of vehicles in Europe, and Ram adapted it for truck duty with a beefed-up torque converter and internal components to handle towing loads. Going in, I actually expected this transmission to be the weak link, since 8-speed units built primarily for passenger cars sometimes struggle when asked to handle truck-level torque over hundreds of thousands of miles. That's not what we found. The ZF8 HP 75 uses a lockup torque converter with a much more conservative engagement strategy than either the Ford or the Chevy. It spends more time in a traditional hydraulic coupling mode during low speed and stop-and-go conditions, only fully locking the converter clutch in a narrower band of steady-state cruising and load conditions. This means less clutch cycling overall, which directly translates to less heat generation and less friction material wear over the life of the transmission. When we pulled fluid from high-mileage Ram 1500s, the fluid condition at 200,000 miles was consistently better than what we saw in either the Ford or Chevy units at comparable mileage, even on trucks that had gone longer between fluid services than Ram's recommended interval. Physically tearing into these units told the same story. Clutch pack wear on the ZF8 HP 75 at 200,000 miles was noticeably less advanced than what we found in the Ford, and significantly less than the Chevy. Part of this comes down to the transmission's wider gear spread across 8 ratios instead of 10, which sounds counterintuitive since you'd think more gears mean more shifting and more wear. But the ZF's shift logic uses closer ratio steps in the gears most commonly used during daily driving and towing, meaning the transmission doesn't hunt between gears as aggressively as the Ford and Chevy units do in similar conditions. Less hunting means fewer shift events overall, and fewer shift events means less cumulative wear on the clutch packs handling each gear change. The valve body and mechatronic unit on the ZF8 HP is a fully integrated assembly, which is actually a downside when something does go wrong, since you can't service individual solenoids the way you can on the Ford. When these fail, and we did see some failures, typically related to the internal wiring harness inside the mechatronic unit degrading from heat exposure over many years, the repair cost is higher because you're replacing the entire unit rather than a single component. But the frequency of these failures across the trucks we inspected was noticeably lower than the frequency of clutch pack or valve body issues on the Ford and Chevy. When they did occur, they tended to show up as a specific fault code and limp mode rather than a gradual degradation in shift quality, which actually makes the problem easier to diagnose and catch before it turns into a more expensive repair. We paid particularly close attention to the friction material itself on the ZF unit, since that's the component most directly tied to how many miles a transmission can go before it needs internal work. The clutch packs in the ZF8 HP 75 use a friction material formulated for a wider temperature tolerance than what we found in either the Ford or Chevy units, which makes sense given the transmission's roots in higher performance European applications where thermal management was already a priority during development. Combine that more heat-tolerant friction material with a converter strategy that generates less heat in the first place, and you get a compounding advantage that shows up clearly when you're looking at clutch pack thickness measurements across trucks at the same mileage. One more factor worth mentioning is fluid type and service intervals. Ram specifies a fully synthetic ZF fluid with a much longer service interval than either Ford or GM recommends for their 10 speeds. Despite the longer interval, the fluid condition held up better in our inspections. This tells me the fluid formulation itself, combined with the more conservative converter lockup strategy, is doing a lot of the heavy lifting in keeping this transmission healthy over high mileage use. Owners who stuck to the recommended service schedule, even at the longer interval, showed excellent results at 200,000 miles, with clutch material still well within usable spec on most of the units we inspected. So, based on everything we found tearing into these 3 transmissions across trucks, with real 200,000-mile histories, the Ram's ZF8HP75 came out as the clear winner in terms of long-term durability. It wasn't close. The combination of conservative torque converter lockup strategy, wider clutch material margins, and a fluid formulation that holds up better over time gave it a real advantage over both the Ford and the Chevy units. The Ford 10R80 came in second, held back mainly by early software calibration issues that caused accelerated wear in trucks that never received the updated shift mapping, along with a converter that benefits significantly from more frequent fluid service than the factory schedule suggests. The Chevy 10L90, despite sharing core engineering with the Ford, came in third, primarily due to GM's more aggressive converter lockup calibration aimed at fuel economy numbers, which consistently showed up as increased clutch wear and valve body issues in our inspections. If you're shopping for a used half-ton truck with high mileage and transmission longevity is a priority for you, here's what I'd actually do based on everything we found. If you're looking at a Ram 1500 with the ZF8HP75, verify the fluid service history, but don't panic if it's slightly past the recommended interval, since this unit tolerates that better than the other two. If you're looking at a Ford F-150 with the 10R80, specifically ask whether the truck received the transmission control module software update, which most dealerships can check against the VIN, and budget for a fluid service sooner than the 150,000-mile factory recommendation if the truck has towing history. If you're looking at a Chevy or GMC with the 10L90, prioritize trucks equipped with the Max trailering package and its larger transmission cooler, and get a fluid analysis done before you buy if the truck has any towing history at all, since this is the platform where we saw the most variability in condition at high mileage. It's also worth addressing something viewers always ask about in the comments on videos like this, which is whether transmission cooler upgrades or aftermarket tuning change any of these results. In our sample, trucks with aftermarket auxiliary coolers added, regardless of brand, showed measurably better fluid condition and less clutch wear at high mileage compared to trucks running only the factory cooling setup, especially on the Chevy platform, where factory cooling capacity was the biggest limiting factor we found. This isn't a paid endorsement of any particular cooler brand, it's just consistent with basic thermodynamics. Heat is the primary driver of friction material breakdown in every automatic transmission, and anything that keeps the fluid running cooler under load extends the life of the clutch packs regardless of which manufacturer built the unit. If you tow regularly and your truck didn't come with the largest available cooler option from the factory, adding one is one of the cheapest insurance policies you can buy for long-term transmission health. None of these transmissions are bad. All 3 are capable of reaching 200,000 miles and beyond when properly maintained, and I want to be clear that neglect will destroy any of them regardless of design. But when you're comparing well-maintained examples against well-maintained examples, the differences in engineering philosophy between these 3 manufacturers show up clearly on the lift and in the fluid pan. Ram's more conservative approach to converter lockup and its fluid formulation gave it a genuine durability edge in this comparison. And that's the kind of finding that actually matters when you're deciding which truck to put your money into for the long haul. If you found this breakdown helpful, subscribe and hit the notification bell so you don't miss the next comparison, because we've got a diesel transmission durability test coming up that covers the Duramax Allison, the Power Strokes 10R140, and the Cummins Eisen transmission using the same real-world teardown approach. Drop a comment below telling me which truck you're currently driving and what mileage you're at. I read every one of them, and if you know someone shopping for a high-mileage used truck right now, share this video with them before they make a decision they might regret. Thanks for watching, and I'll see you in the next one.